And we're back with another exciting PicoCTF challenge, transformation. Description, I wonder what this really is. And we have a file that we'll download. And we have this string of characters and instructions. And this can look very intimidating. On first glance, you may not be able to immediately tell what it is. I knew it was Python, but if you didn't know, I would suggest just taking little snippets and pasting and seeing what's suggested. And Python is one of the things that's suggested. If that first hit didn't get it for you, you might want to try something like for in range 0, just anything that's distinctive, and see what you get. And it looks to be Python, so perfect. We'll go with Python. And the way I like to approach something like this is too much for me to do in my head. It's very dense. I'd like to bring this out into an editor and then be able to have all kinds of nice facilities. I don't want to do this on pencil and paper. So I'm going to go into Visual Studio Code. I'm going to make a new file called transformations.py. And what's going on is this is called a list comprehension. And it's a special feature in Python, list comprehension, just so you can see I'm not making this up. And it's a really nice way to make lists. What it essentially allows you to do is it allows you to do filtering and transformations and all kinds of things like that in a very succinct and compact manner. So as an example here, so we have a definition of fruits already. We have a list of fruits. And then we have a new list that's being made. And it's saying X for X in fruits if A is in X. So you start here, and X is going to take the value of each fruit in turn. So it'll iterate through. So for example, in the first go, it'll be apple. Apple will be X, and it'll ask the question, is there an A in apple? Yes. Okay, then we continue. And then here we could do transformations if we wanted to. So maybe we wanted to do to uppercase or something like that. But here we just take it as is, and we put it in the new list. So we do the same thing with banana. Banana has an A, so it's included in the list. Cherry does not have an A, so we won't get cherry in the new list. We won't get kiwi. We'll quickly take a look, and there we see that matches exactly what we thought. And if we wanted to get cute and do something else like a transformation, we could do it there. Maybe, if it runs. Yep, perfect. So you see we added that transform. So for each of the X's, for each of the things it iterates over, we performed a transformation. And we could change our filtering criteria, or we could remove it. Boy, I'm hoping this is not so slow. It seems to be. Anyway, there you go. Kiwi was the only thing with an I. So now you get the idea of list comprehensions. So as we go in here, one of the things I'm going to do is I'm going to space this out so I can see what's actually going on. And actually, we may be able to just format the document. We have to install it. We'll install, and we'll see if it does a better job than we do at the end. But I'm just making it so this is less of just a one-line blob of text and more something that I can make sense of. So I'm matching up the different elements, and I'm indenting them a bit and breaking things out just so it's kind of hierarchical. Okay. And this may cause Python to break and complain. We'll see. But the important thing is, okay, now I can kind of actually, maybe just once more to see exactly what operations are happening. Plus, okay, cool. So let's add a flag. So let's say we were going to give it PicoCTF my test flag 1. All right, cool. And then we think that this is the encryption. So flag encrypted is what comes out of this guy. And then we'll print it. And we will take a look at this, see if this runs. Oops. And it does, and we get some Japanese looking characters out of it. So let's take a quick look at what we actually got. So what was this encrypted? Let's drag this into VS Code as well. And we can see we have Japanese characters. So we seem to be doing the encryption okay so far. So one of the things that I would like to do is, this is really nice. We're talking about how it compacts things down quite a bit, list comprehensions. But it's also difficult to debug and get inside of. What would be a lot nicer is if we broke this out into a more, I guess, procedural attempt. So what we're going to do is we're going to create the exact same thing, but we're going to do a while loop, and we're going to slowly build up this list and be able to inspect. And I'll show you how much nicer and easier it is to debug using this. So the first thing I'm doing is I'm looking at the bounds that we iterate over. So we go for I, that's our counter, from 0 to the length of the flag. And this just means we're going by 2s. So start at 0, and the next time through we're 2, 4, 6, 8. So here we go. We've got our iterator I, while I is less than flag. And then we know we want to do I equals I plus 2. All right, so that's the first step in us translating this. Then we do this operation, which we'll look at in a minute. And we'll call this first. And it doesn't like something about that. What did we miss? What did we miss? I see. So it's actually more like that. Okay. Then we have another operation that happens here. I'm just working from the inside out, so just like you would do with math back in school. And then we add them. Combined equals first plus second. All right, and then we do this CHR. Don't know what that is yet, but we'll find out soon. And that seems to be our encrypted character. And then we've got one last thing on the very outside where it does this join. And this is a way of joining together a list. So if you had something, say like A, oh, so slow, P. I'm trying to write Apple. We're not going to get there. So I'll stop there. If you had something like this and you want it to be one word, you would use this kind of construction. And actually, let's start using the debugger, and I'll show you guys why this is so valuable. All right, so if we go down to the debug console and we wanted to do operations, so I'm at the very bottom down here, I'm assigning, we'll call it our list. So we've got our list. Now we want to see, what does this code do? Maybe you don't trust me when I say that it combines it. And there you see, it brings it all into a string. So that's cool. So we might also wonder, well, our flag is PicoCTF. What is this when the flag is, for example, 1? I think I missed a little bit there. Okay, so I just cleaned it up. So what does all that work out to be? Well, that's a pretty big number. Let's not shift. So shifting, we'll talk about in a minute, but you can think of it, especially with binary shifts, as multiplying by 2 each time. So essentially we're multiplying by 2 8 times. So ord of flag at 0, so ord of P is 112. Well, that kind of looks like we're getting the character value, the encoding. So let's Google Python ord to see what that's doing. And it returns the integer that represents the characters given, specifically in Unicode. Okay, cool. And we know that shifting, so you can imagine, for example, if we had the number 10, adding another 0, you can think of that as shifting. So this used to be in the tens place, now it's in the hundreds place. Let's make it 12, just so that's a little more instructive. So right now the 1 is in the tens place, and the 2 is in the ones place, for a total of 12. If you were to add a 0, you can think of it as if you shifted these original 2 left 1. So now the 1 is in the hundreds place, and the 2 is in the tens place, for 120. So when we deal with binary, for example, we might have something like a bunch of zeros and then 1, 1, 0. So if we were to, say, shift this all over by, let's just add a 0 for the time being. Let's simplify. Okay. So right now, this is 3 because you have a 1 in the ones place and then you have a 1 in the twos place where it's binary. So you have a 1 place, 2 place, 4 place, 8 place, 16, because you're doubling every time. That's the way binary works. Whereas base 10, you have a ones place, a tens place, a hundreds place, a thousands place, etc. So by adding a 0, we're doubling from 3 to 6. We have a 4 here, and we have a 2 here, and we have nothing in the one spot. Okay, so we're starting to shift things over. All right, cool, and we get a big number. And then we can see we take the character value of the flag at the next location. So in this example, the character value at the I. We add those together, and then we take our character. Okay. So that's basically what I was setting up down here, was I wanted to show you guys that, and I'll finish up transcribing here by making a list. We're going to add that to our list, append our encrypted character, and then at the very end, once we've looped through everything and encrypted everything, what we want to do is we want to do that join that we saw above, and then we should have identical code. So our encryption, or our encrypted flag. Let's say that, and let's print it out. And we're also going to check that they're the same. Our encrypted flag is that equal to, what was it? Flag encrypted, which is, I'm going to name better. Their encrypted flag. That's what I'd like to call that guy. All right, so we're going to rerun this by just doing this restart button. And we're going to let this run through because I just want to show you that, yes, we did in fact, we're printing these out at the bottom. And oops, minor mistake. That's no longer the name, right? It's their encrypted flag. But since I have this debug session, we can just go down here and we can just check by writing our code down here. And it says true. Yes, so what we've done represents what they had. So now let's walk through it just a little bit because this is a more involved one and I want everyone to kind of have some intuition for what's going on. So we'll set a breakpoint at the beginning and we'll restart to go look at this again. And we are going to look at this step by step as we go over it. So F10 to step over. So first, we see is a huge number, Unicode. Second, keeps its value. And let's look up in a Unicode table what these guys are. I, over here, have a Unicode table. And this is all done in hex. But that's okay. We could just break out a calculator if we needed to, set it in programming mode. And we know we have 105. And we can see in hex, that is 69. Is that right? It is. So you can see there, 0060, and then going vertically, I look for 9, and it's the I, which makes total sense because PicoCTF, we're on the I. But what is that hugely shifted number? First. So when we look at first, it's 28,672. What is that in hex? I would love to know what that character is. 28,672. So we can see that's 7,000 in base 16 is what you see at the end there. So let's take a look at that. $7,000. And so you can see these are all Japanese characters. So what seems to be happening is we're being shifted all the way up into the Japanese character set from the English character set. And we combine those, and then we want to know what is that in Unicode. So we're doing essentially the exact same thing we just did, where we looked in that table and we said, what is that? And the answer is, it's a Japanese character. So now we've combined P and I into this Japanese character. And since this is a bit involved, much more so than our prior challenges, I wanted to actually break this out for you guys, just so you saw. So at the top, we have our plain text flag. So this is what's being passed in. This is what we want to get from our encrypted ciphertext at the bottom. And we're going two at a time. So for example, P and I, and we're breaking these out. We're saying P, what is your ordinal value? What's your Unicode? And the answer is 112, which looks like this in binary. You're gonna have to just trust me if you don't know binary, that's what it looks like. And then we're shifting it, left 8, which again, remember, think like base 10. That's like adding a bunch of zeros. So here we can see the original numbers that we had in red, and then we've added on 8 zeros, which is the same as multiplying by 2 8 times in terms of the decimal equivalent of it. Then on the other end, for the I, we're asking just, what's the Unicode character? Well, 105. And then that's what it looks like in binary. And then as we go down, what we can see is we're adding them. And the interesting thing is, we've essentially made a slot where we can put both numbers. So a Unicode character is 16 bits, excuse me. And we have two 8-bit numbers. So obviously we can put one on the high end and one on the low end, and they both fit. And then we ask, what is this character, this huge number? And it's this Japanese symbol. Cool. So how do we go back from that? Well, I'd like to present this very simple diagram. So let's imagine is we just have two 2-digit numbers, and we're looking to store them in one 4-digit number. So we have 55 and 66. Those were our original two. So we're shifting left, which is the same as multiplying by 10 twice, the first number, and then we're adding the second number. So the encrypted flag would look like 55, 66. This is really easy for you to just eyeball and just say, well, okay, 55 and 66 are my numbers, but we need to tell the computer how to do this. And the way we're going to do that is we're going to grab the high number first by shifting right twice, which you can think of as just dividing by, you can think of it as canceling out these numbers. Actually, that would be the best way. It is division, but it's also division with flooring, meaning if you were to divide 5566, you would actually end up with a decimal, right? You would end up with divided by, if you were to divide it by 100, 5566 divided by 100, you would end up with 55.66. But that's not the kind of division we're doing. We're doing division where you drop anything that's not a whole number. So you end up with just 55. So you can think of it as just canceling out these two numbers. That's what the shift is going to do. So we'll discover that we have 55. And then how do we get 66? Well, we need to subtract the 5500 from this number to end up with 66. So we know we have 55. We're going to shift it back, and we're going to subtract it from our encryption. So that's what we're going to do now. Hopefully that all made sense. And if not, I'm sorry. I stream, or I try to stream regularly. And if you would like to join the chat and ask any questions, you're more than welcome to. Oh my gosh, I had not shifted screens. Sorry. Okay, so we're going to take the larger end, we're going to shift it off, and we get 112. And 112, when we take it to a character, is P, which is what we were hoping for. So that's the P in PicoCTF. Cool. So now we know we have 112. So we want to take the ordinal of our encrypted flag, and we want to subtract 112 shifted 8. Oops, not defined, sorry. Our encrypted flag. Nice. So what this is doing is, if you went back to that image we had before, we have 5566, and so to get to 66, we need to subtract 5500 from it. So that's exactly what we're doing. So we're subtracting the larger number. So now if we were to make this codified, here we have our plain text list equals, it's a new list, and we want to just start adding these two guys. So we figured out how to do it down here. And now we'll just bring it on in, and we will try in our Japanese characters in just a minute. So we know we want that to be I, to be the first one of our pair. First char is equal to this guy, and then remember this is a number, so then we need to apply character to it. And then you know what, we are going to want that number though for when we shift things in the second half. So we'll do first int val, integer value. To get our first character, we'll just take first int val and turn it into a character. And then to get our second character, we will say we want the ordinal value, of our encryption minus first int val shifted to left. And I don't want to throw on another method here, so we'll have an intermediate just like we did before, and our second char equals second int value as a character. Why is it complaining? Oops, it's missing a comma, or a curly bracket. And then our plain text, so this is what we have unencrypted. We will append first char and append second char, and then at the end we'll do our familiar trick of joining them, and we will print what that is. All right, let's see how close we got. Remember, we're looking for PicoCTF. Not close, that's the answer. I'm seeing one problem immediately. Remember, this is supposed to be the very next guy, so it's supposed to be I and then I plus 1 to have that pair of like Pico, P and then the I, C and then the O get combined. So I messed up there, 100%. Still saying not in range. I think maybe the order of operations is not what I think. I want this to be shifted because we want this to be the huge number first, and then the huge number gets subtracted. So I think maybe that's the issue. All right, I guess I'm gonna have to actually walk through it. So from the top, first int value, 112, that's good. That works. That gives us our P. Yeah, I'm happy with that. Okay, I was wrong to go on to the next one because it's on the encryption that it takes a pair. on the decryption, it works on a single character. Let's say the Japanese characters are more dense. All right, so that was a mistake. So now let's change our breakpoint. So I'm happy to that point. And I definitely found an error. My fix was not a fix. My fix broke it more. All right, P. And we have this ordinal of 0 minus 112. Boy, that looks right to me. All right, let's find out exactly what these values are here. Yeah, that looks like a large number. That could be Japanese characters. Infal shifted 8. Boy, that part looks right too. All right, let's put them together and see what we get. 105. Boy, that looks correct. CHR of 105. I think that's an I. Why are you? It is. Okay. Why is this failing? And it's not anymore. So I think it was a combination of, I made a mistake here when I added this, and this was the actual mistake, was not having this properly bracketed as it needed to be. So I introduced a bug, then I fixed this bug, then I realized that bug was there. Yeah, that's what I'm thinking happened. So let's let this run and let's see what we get as output in our terminal. And we got back my test flag. Awesome. So let's try this. Let's try our decryption. I'm going to just turn off all this other stuff, all the encryption we're doing, because we don't care about that. And our encrypted flag. So one thing I hope you guys are seeing is this is messy, and if you're having trouble, you shouldn't feel bad. It's not always easy to think through these. There's a lot of places you can go wrong. And there we go. 16 bits instead of 8, which fits in with what I was saying, where we were compacting two 8-bit numbers, well, characters that fit in 8 bits, which, yeah, you can think of as 8-bit numbers if you want to. We were compacting those and putting them into one 16-bit number. And this is a useless hint. You may find some decoders online. Maybe, I don't know. Oops, that's not a flag. Come on. Give me the flag. Perfect. Hopefully you found this instructive. Sorry it was a bit of a mess. If you enjoyed it, please like and subscribe. Bye.